Hi there everyone, and welcome to my biggest motor testing video ever. In this video, we are going to be testing over 30 different motors for 3.5-inch Cinewhoops, 4-inch Freestyle quads, and 5-inch Ultralights, from the likes of Axis Flying, Beta FPV, Brother Hobby, Diatone, Emax, Flyfish, Foxeer, FPV Cycle, Gep RC, RC Empower, T-Motor, iFlight, Umagod, and X-Nova. It's a massive amount of testing, and this video has taken a lot longer than I expected to make, but it's all done now and I can't wait to share the results with you. Let's not waste any more time, let's dive right into it. If you're looking to make the most of your FPV experience, why not check out my website aosrc.com, where you'll find my latest product recommendations for motors, batteries, props, electronics, and much, much more, all backed up by the kind of scientific testing you'll see in this video. And once you've got the perfect hardware, you'll need the perfect tune. And I've just released my new Betaflight 4.5 tuning guide that covers filters, PIDs, and rates, and that's available in PDF format over on my Patreon. There are links to all of this down in the video description, so don't miss out. Before we dive into the test methodology and the test results, I just wanted to show you the huge variety of motors that we're going to be looking at today. We've got some really small narrow motors like this 1606 from Diatone and this 16mm motor from FPV Cycle. But we've also got some really wide stators. We've got this 2203.5 from iFlight and these 23mm motors from FPV Cycle. In terms of weight, we've got some lightweight motors like this X-Nova 1804. We've also got 1804s from Flyfish, T-Motor and Gep RC as well. And then on the heavier end, we've got this 2006 from Axis Flying and a 2006 from Beta FPV as well. But it's not just variety in size and weight, we've also got variety in kV. So this RC Empower motor has 1800 kV, designed for 6S Ultralight 5-inch. And then at the other end of the scale, we've got this 2105.5 from Foxeer with 3650 kV, over twice the kV of the motor from RC Empower in a very similar size. I think with all of this variety, we are going to be learning so much when we get into testing these, and that's what we're going to do next. In order to be able to fairly compare all of these different motors, we need a repeatable and scientific test. And that's what this piece of equipment is for. This is a programmable thrust stand, and it can measure a whole heap of different parameters about the performance of a motor whilst running a set of pre-programmed tests. So here we have an optical RPM sensor at the front. You can see the motor is mounted on this test stand with some reflective tape on it, and this optical RPM sensor can measure the RPM of the motor during the test. We can also measure the torque and the thrust that the motor is exerting using this trio of load cells here. And the motor is being driven using this Mamba F50 Pro 4-in-1 ESC, which is running the latest version of AM32, which is version 1.99 as of the date of recording. This ESC is connected to a huge 50 volt 10,000 microfarad capacitor to smooth out any voltage fluctuations, and the test stand is powered off this 5200 mAh 6S pack that's kept topped up to 24 volts, or if I'm running a 4S test, I've got a 5000 mAh 4S pack and that's topped up to 16 volts. The board back here both controls the ESC so that we can do exactly the same throttle ramp or throttle step each time, and it also measures the voltage and current that's being supplied to the ESC so that we can measure the electrical power and the efficiency of the motor and things like that. As well as running tests with a prop like this one, we can also run tests with a flywheel to measure the torque versus RPM response of the motor as well. Now that you're familiar with the test equipment, it's time to get into the test results, and we're going to start by measuring the kV of all of these motors. It's really important that manufacturers accurately label the kV on their motors because kV has a huge impact on how the motor performs when driven off different battery voltages. I measure kV by driving the motor full throttle at 10 volts and then dividing the RPM measured by the optical RPM sensor by 10 to give the kV in RPM per volt. Let's take a look now at the results of my kV testing. And what you can see is that I've plotted the rated kV of the motors in dark blue, and that's what the manufacturer writes on the motor. The measured kV, which I measure on my test stand, is next to it in light blue. And we should expect, if the kV is rated accurately, that there's not too much difference between what the manufacturer states and what I measure. And that's true for the vast majority of motors, which is good to see, with just a couple of exceptions. The Diatone Mamba 1606 is testing out 500 kV lower than its rating, and that's a huge discrepancy on a 3100 kV rating. That's really going to affect how the motor performs and the type of prop that you'll want to use with it. Also at the higher kV region, we do have the T-Motor Pacer 1804, which again is testing out 250 to 300 kV lower than its rating. And it would be good to see the ratings on these particular motors corrected, made a little bit more accurate, so that we can have all of the motors correctly rated, because it really does help with picking the right prop and the right battery voltage if the motor kV rating is accurate. I've also used the motor kV to divide these motors into 4 categories based on their use case. So at the low kV end, between about 1600 and 2000 kV, that's going to be for your ultralight 5-inch drone running on a 6S battery. So I'm going to be using the HQ 5x3x2 prop to test these and running it at 24 volts. If you go up in kV to between 2400 and 2650 kV, we have the 6S 3.5-inch Cinewhoop category. So we're using a 3.5-inch bullnose prop for these, the HQ T90, and we're running them at 24 volts because that's what these motors are primarily designed for. If you step up even higher in kV, getting now up to about 3000 to maybe 3200 kV, again, that's going to be your 3.5-inch Cinewhoop, so we're using the same bullnose prop, but this time running it on 4S rather than 6S. The highest kV motors, so ranging from about 3400 kV up to nearly 4000 kV, that's going to be your 3.5-inch prop again, but not a bullnose this time. We're looking at a prop with a tapered profile and running it on 4S. So that's going to be for your typical 3.5-inch freestyle application. Now that we have the motor category sorted out, we can look at the performance of these motors. And we're going to start with maximum thrust. This is measured at full throttle with the given prop and battery voltage. And we're comparing these motors not just in terms of maximum thrust, but also on their thrust to weight ratio. Let's start with the 5-inch ultralight category. And here we're looking at 2 things, the maximum thrust that the motor is able to produce and also its thrust to weight ratio. So if you're just interested in maximum thrust, then either the Emax Eco 2 or the Xing 2005 1900 kV are going to be the ones for you. When we bring thrust to weight ratio into consideration, we can see that the Emax Eco 2 really pulls ahead in that metric. It delivers a lot of thrust for its weight. And if you're looking for a drone with the maximum possible thrust to weight ratio, that's going to be a really great pick. Also, as we move down the stack, the RC Power 2104 and the Xing 2203 both also deliver reasonable thrust to weight ratios. And with a slightly lower kV, they may have better efficiency, but we're going to look at that next. Moving on to the 3.5-inch 6S Cinewhoop category, and again, we've got some standout performers. Up at the top in terms of maximum thrust are the Foxeer Datur 2105.5, the Axis Flying 2006, and the Beta FPV Lava 2006. These are all big motors, and so they deliver a lot of thrust. But we also care about thrust to weight ratio. And if you're looking for some lighter motors that also have really good thrust to weight ratio, the Umagod Aerolight does really well, as does the GEP-RC Speedix 1804. All of these motors actually achieve very similar thrust to weight ratios to the Axis Flying 2006. They're just a lot lighter. So if you're looking for a slightly lighter build, they could be the one for you. And the Foxeer Datur and the GEP-RC Speedix are both made by RC Power. So it's no surprise that they're doing really well in this test. If you're flying your Cinewhoop on 4S, you're going to need a motor with a slightly higher kV. And RC Power top the charts here with their 2104 3000 kV option. But it's a very competitive field. Both Emax, Axis Flying and T-Motor all make motors with comparable maximum thrust. So where you're going to separate out these motors is on their thrust to weight ratio. So RC Power and T-Motor come out slightly ahead on that metric because they deliver more thrust despite the motor weighing slightly less. In the 3.5-inch freestyle category with the higher kV, I think again it comes down to thrust to weight ratio. The Foxeer Datur 2105.5 delivers the most thrust, but it's a very big heavy motor, and so it really suffers in terms of thrust to weight ratio. Something like the Axis Flying 2004, the FPV Cycle 16mm, or the Flyfish Flash 1804 are going to be better choices because they deliver much better thrust to weight ratio, and in that slightly smaller, lighter size, that's going to make the bigger difference. Now we're going to look at the efficiency of the motor. And this is measured by looking at the mechanical power that the motor is able to deliver versus the amount of electrical power that it's consuming. A motor that is producing more mechanical power for the same amount of electrical power is more efficient, and that's going to give you longer flights with the same battery. Let's start with the Ultralight 5-inch category, and this chart shows you the efficiency of a motor across its whole power range. So you can see if a motor is more efficient at low throttle, at high throttle, and whether its efficiency varies depending on how much power it's delivering to the prop. We can see that the FPV cycle 21mm with its super low kV, 1620 kV, is really efficient across the whole power range, but it doesn't produce all that much power even at maximum throttle. Something like the Emax Eco 2 or the Zing 2005 is able to produce a lot more power, albeit at a slightly lower efficiency, and the Emax Eco 2 does a really good job of remaining pretty efficient across the whole power range, whereas something like the Zing 2005 is less efficient at low throttle and its efficiency improves higher in the throttle band. These charts can give you an idea of whether a motor is right for just cruising around. So something that's very efficient down in this sort of 50 to 100 watt region is going to be very good for cruising. Or if you're looking for a motor that's more efficient higher in the throttle, you just can look more towards this end and see which motor is going to be better for that. Looking at the 6S Cinewhoop motors, we see something really interesting, which is that all of these 1804 size motors, whether from T-Motor, Flyfish or Gep RC, are all struggling with efficiency at higher power levels with this 3.5-inch bullnose prop. And this indicates that if you're flying this type of drone on 6S, then you're going to need a bigger motor than an 1804. An 1804 is just not a big enough motor to drive that prop with any efficiency. Looking at the larger 2004 and 2006 size motors in this category, we see that they all have reasonable efficiency and a lot of them can also deliver a lot of power. But the best performer in terms of efficiency is the FPV Cycle 23mm motor, which although it doesn't deliver all that much power, it does so very, very efficiently. So if you're looking for a lot of flight time out of your 3.5-inch 6S Cinewhoop, then the FPV Cycle 23mm 2350 kV might be a really good choice. That or the Zing 1806. But I hesitate to recommend this one because it has a very strange prop mounting pattern. It's got a 6mm T-mount prop mounting, so it won't fit most standard T-mount props for 3.5-inch Cinewhoops. So this, I guess, is a bit of a shame because it's otherwise quite a good performing motor in terms of efficiency. Looking at the 4-inch Cinewhoop motors, we see that the Emax Eco 2 is doing really well in terms of efficiency here. Both the peak efficiency and also the efficiency at maximum power are both really, really good. And then we have a whole group of motors, including the RC Empower, the T-Motor, Flyfish, Brother Hobby, all of these guys all clustered together at a very similar efficiency level. The Tiretone Mamba 1606 is struggling a bit in this test, and it's not producing much power or delivering much efficiency, which makes me think that it's not very well matched to this 3.5-inch application. In the higher kV 3.5-inch freestyle category, we can see that there are really two motors to beat here. We've got the FPV Cycle 23mm and the Axis Flying at 2004. Both of these motors are performing really well, with the edge going to the Axis Flying because of course it delivers more power at maximum throttle. For cruising around, the Xnova 1804 also does really well. It's very, very efficient and of course a much lighter weight motor. Then looking at some of the other ones, we have the motors from T-Motor and Flyfish, the 1804s. They're not doing so well in terms of efficiency compared to something like the Xnova, but again, they are lighter weight motors. And they have good efficiency at low power levels. So for cruising around, they might be exactly what you want. If you're looking at something like the RC Empower 1507 or the Foxeer Dato 2105.5, they're going to be for applications with a higher power level because they're not all that efficient low in the throttle and they get more efficient at higher power levels. The final data that I want to share with you before we jump to conclusions and recommendations is motor responsiveness. And this is a measure of how fast a motor can accelerate and decelerate a prop, and that's really important for keeping the quad stable in the air in response to wind or other turbulence. Every time the quad is perturbed in one direction, the motors need to change their thrust level, change their RPM very, very quickly to stabilize it. The faster a motor can do that, the smoother the footage from the quad is going to be. So it's really important. I test this by measuring how fast the motor can accelerate and decelerate the prop 40 times from 10 to 50% throttle. Then I take the average of the acceleration and deceleration. And that's what we're going to look at now. Starting with the Ultralight 5-inch category, I tend to find that motors with a tall, narrow stator A higher kV and strong magnets do really well in the motor responsiveness testing, and we can see that the Zing 2005 1900 kV is coming top of the charts with an average of the acceleration and deceleration of just about 140,000 RPM per second. One of the challenges with this motor is it's got a slightly strange T-mount layout. It's a 6mm T-mount rather than the more common 5mm T-mount, and this means that it doesn't work with the vast majority of props out there. It only works with props from iFlight. If you move down to the Emax Eco 2, it also performs really well, and it supports both 5 and 6mm T-mount props, so you can use any T-mount prop with the Eco 2. So that would probably be the one that I would choose based on that. And then we have the RCM Power 2104, 1800 kV, a little bit of a lower kV, and that is hurting it in the responsiveness test, I think. And then we have the Zing 2203, which has a very wide flat stator, and that's also going to hurt it in terms of responsiveness. The FPV Cycle 21mm has a pretty low kV, and that's why it's probably performing a little bit worse. And then we have the Flyfish Flash 2004. It's got a lower kV, and I guess the magnets in this motor are not as strong, or the magnetic design is not quite as good because it's only managing about 112,000 RPM per second on average. Looking at 6S Cinewhoop motors and the big motors, the 2105.5, the 2006 size motors from Foxeer Axis Flying and Beta FPV are doing really well in terms of responsiveness. There's no surprise there. These are really big, powerful motors, so they should have excellent control over that 3.5-inch bullnose prop. Moving down a little bit in motor size, we've got the lighter weight and slightly smaller overall Aerolight, the Zing 1806 and the FPV Cycle 23mm. These are all quite a bit lighter weight than the 2006 or 2105.5 size motors, but the responsiveness is not quite as good just because they haven't got so much torque. And then as we move lower to the 1804 size motors, these are going to be the least responsive. And probably if you're focusing on responsiveness and getting super smooth footage, you're going to want to opt for one of the larger motor options here. In the 4S Cinewhoop category, again, there's a lot of competition here, and there are a range of really great options. The RCM Power 2104, the Axis Flying, and the T-Motor all do really, really well in terms of responsiveness, and any one of those would be a very good pick. The Emax Eco 2 is also worth a mention just because it's very good value, and it scores very nearly as highly in terms of responsiveness. So any of these would be a good choice for a 3.5-inch Cinewhoop on 4S. The final category is this higher kV 4S 3.5-inch category, and here we see the benefits of tall, narrow stators in terms of responsiveness, because the RCM Power 1507 and the FPV Cycle 16mm are doing really, really well in this responsiveness test, and they're matching much heavier motors like the Axis Flying 2004 or the Foxeer Dato 2105.5. They are trading blows with those motors despite weighing a lot less. So if you're focused primarily on responsiveness, then going for a tall, narrow stator can be really beneficial in terms of the responsiveness you get for the weight of the motor. The 18mm motors in this category, the 1804s, are less responsive because they're just smaller motors, but the X-Nova 1804 is doing really, really well here. It's demonstrating why it's a really good choice if you're looking for a lighter weight motor for 3.5-inch freestyle. So I would definitely look to that to be a really good choice on the slightly lighter end, because it's still really responsive despite being a lot lighter than something like a 2105.5. In the interest of keeping this video short and to the point, I'm not going to go through all of the tests that I conducted on these motors in detail here. All of that raw data is available on my Patreon, and if you want to check that out, there are links down in the video description. Now let's head on over to the bench and I'll give you my recommendations on which motors I would pick for each of these applications and why. So let me take you through my motor recommendations for each of the different categories, starting with the 5-inch ultralight category. And I'm in two minds about this Zing 2005. It's a great performing motor, very responsive, very powerful. But it has this non-standard prop mounting layout, the 6mm T-mount, which means that it's not compatible with the vast majority of T-mount props. You can use the iFlight 5030, which is a very light tri-blade prop with this motor, and if you like that prop, then this could be a great motor for you, because they're really well paired together. But if you're looking for more variety in terms of which props you can use, then you're going to struggle because of the non-standard prop layout. The RCM Power 2104 doesn't have this problem. It's got the standard 5mm T-mount layout, which is you can use with the vast majority of props out there. It has really great performance, responsiveness. It's a good all-around motor for that 5-inch ultralight type application. But the winner, I think, overall is the Emax Eco 2 2004 2000 kV. This has great performance and great efficiency in a very economical package. It's got a very good price point, and it supports both 5 and 6mm T-mount props, which means you can use any 5-inch ultralight prop you could think of on this motor, and it's going to work just fine. So it kind of combines the best of both the iFlight mounting and the RC Power more standard 5mm mounting in one package. Looking now at the 3.5-inch Cinewhoop motors, and starting with 6S. And what I've learned is that on 6S you need a nice big motor to provide plenty of torque to drive the prop. And the Foxy Adapter 2105.5 2650 kV was a really good performing motor for that. This is a pretty big, powerful motor that's going to be suitable for driving those props. And it's got a 5mm T-mount, so it's going to work with most of the 3.5-inch bullnose props that are out there. This is a really nice choice for this application, and I think it's made by RC Power, so you can be confident that the quality of the motor is going to be there. Moving on, we have a Beta FPV Lava 2006, which, and I'm not often one to recommend Beta FPV products, but this motor performs really, really well, and it's designed specifically for 6S 3.5-inch Cinewhoops. The only slight caveat I would put on this motor is that it only has 2 screw holes for the prop, which means that you should be careful, because if you strip one of them out, you might not be able to use the motor anymore. I would have preferred to have seen 4 screw holes, which is more typical, and basically that gives you a set that, you know, can get damaged, but you can still use the motor because you can use the other set of screws. And finally, we have the Axis Flying 2006, another big chunky motor, perfect for 3.5-inch Cinewhooping. And this motor performed really well, great in terms of responsiveness and top-end power, and a solid recommendation. If you're only Cinewhooping on 4S, you can consider a slightly smaller motor because you're not going to be driving the prop quite so hard. And there are quite a few good options here. We'll start with the RC Power 2104 3000 kV. This has great responsiveness, great efficiency, great top-end power, and the quality is going to be there because it's made by these guys. The T-Motor F2004 is another good choice. Again, great responsiveness, great top-end power, good efficiency, and it's made by a well-known and reputable motor manufacturer, so you can be confident on the quality. And then finally, we have the Axis Flying 2004. Similar to the 2006, this is just a slightly smaller version with a slightly higher KV, more suitable for 4S. And yeah, I mean, it's the same as the other motors. It's got good performance, it's got good responsiveness, good efficiency. Overall, it's a good all-rounder. And Axis Flying have been making motors for a little while now, and I've overall been impressed with the quality. So you're going to buy any of these based on price because they're very, very similar in terms of performance. If you're looking for a value option in this category, then we also have to recommend the Eco 2 because you can get that in 3000 kV. It doesn't perform quite as well as the other motors we've looked at in terms of its overall performance, but based on value, you can't do much better. Finally, let's take a look at the 3.5-inch freestyle category, that higher KV sort of category. And we'll start by looking at the FPV Cycle 16mm, and I'm in two minds about recommending this one because again, it's got quite a non-standard prop mounting configuration. It's got an M3 shaft with an adapter that fits props with a 5mm central hole. So that means that you can't use T-mount props with this motor, and those are the most common props at this sort of size, so that can be quite limiting. But it's a great performing motor, particularly for its weight. So that's something just to consider. In terms of cruising for long periods of time, doing a bit of long range, maybe 4-inch long range, the X-Nova 1804 is a great shout. This is a nice lightweight motor. It's pretty efficient, plenty of torque and responsiveness for handling a slightly larger 3.5-inch or maybe 4-inch bi-blade prop. And it's got the right KV for 4S, so you want to fly something like a 4S lithium ion, this is going to be the one for you. If you want a bit more punch, then you could look at this GEP RC 1804. It's got a lower KV, which means you're going to run on 6S rather than 4S, and that's going to give you a bit of extra performance, a bit of extra speed and power. And this motor is also going to be perfect for 3.5 or maybe a 4-inch bi-blade prop, depending on what you want to do. So they're both good options, and you'll pick the one that's right for whatever you like. All right, so that brings us to the end of this video. A lot of testing, a lot of data, and a few conclusions and recommendations as well. Let me know what you think down in the comments. Did I get the recommendations right? Were there motors that I missed out that I should have tested? I'd love to hear what you think, and obviously I'm going to read all the comments and try and fold that into future test work. That's all I have for today, so make sure you check out the links in the video description to my website and to my Patreon to learn more, and I'll see you in the next one. Happy flying!